Hi everyone, good morning. Welcome to this webinar. Today's topic is enabling consistent app delivery in Microsoft Azure and Azure VMware Solution. We have been, doing this webinar on a monthly basis, and we are running this currently in the PST time zone. So thanks a lot for attending in whatever time zone you are in. This webinar is very exciting, as the enterprises are migrating their workloads across on-premises data centers and cloud environments. It's becoming more and more complex, to enable that workload portability and create consistent delivery of applications. So you will learn a great deal on how to solve that problem, and Abhinav is going to go through describing and walking you through, and with a great demo as well on how to resolve that issue. There are just some housekeeping guidelines before I turn it to Abhinav to begin his presentation. So it's about 60 minutes long, and there will be a presentation, and Abhinav will be showing you a live demo as well, and we can keep it interactive and engage in Q&As as well. So you can put your questions on the Q&A panel, and we'll keep it interactive during the webinar and answer your questions. So the session is being recorded. You will get the recording as well as the slides in a follow-up email. So don't worry about where you can access the deck or the demo. And if you find the content really useful, then feel free to share it with your coworkers, because those of you who are not who are not able to make it this time, I highly encourage them to maybe register for the next one. So because we have this on a monthly basis. Again, you have the Q&A window to ask questions. So let's keep it more interactive so that we can get all your questions answered. So without further ado, let me introduce you to our speaker today, Abhinav and Vijendra. Abhinav, over to you.
Thank you, Sundri, and hello, everyone. Thanks for joining this webinar. My name is Abhinav Modi. I'm a product manager with the Avi Networks team, now part of VMware. With me, I also have Vijendra, my colleague, who's also a product manager with the Avi team. As Sundri mentioned, we'll be looking at how we can enable consistent application delivery in Microsoft Azure and Azure VMware Solution. A quick note on the agenda. So we'll be looking at what the current landscape around hybrid cloud environments are, what some of the use cases we are seeing from our customers as well as the industry, and what requirements they bring for application delivery. We'll take a very quick look into the Avi Networks solution, which is also family called the VMware NSX Advanced Load Balancer. We'll see how we integrate with Microsoft Azure, the native public cloud offering from Microsoft, as well as the Azure VMware Solution, which is a VMware solution provided by Microsoft Azure, by Microsoft, called AVS. Finally, we'll be doing a demo, and then we'll have some time for Q&A as well. Feel free to put your questions in the Q&A window, as mentioned. So what are some of the key aspects around the industry trends which we're seeing? The recent Flexera State of the Cloud report showed that more than 80% of the enterprises who were polled have a hybrid cloud strategy. More than that, have multi-cloud strategy. So they're running on an average around two plus private clouds or private data centers, as well as multiple public data centers as well. The reason they do that is as follows. The first is application modernization. Given that customers are moving towards some of the container services, they would like to be able to be more proximal to Azure services, such as AKS or the community services, and standardize on that for application transformation. So they may be using Kubernetes and OpenShift on premises today. and they would want to use similar technologies in their public cloud journey as well. The second and third reasons we typically see is data center footprint reduction. So a lot of customers want to reduce on their capacity in the private data center, or even exit it sometimes in favor of a more public cloud approach. So in that case, what they want to do is either eliminate their data center or right size it so that they have more presence on public cloud environments such as Azure or Azure VMware Solutions. Uh, Third, we're seeing data center expansion. So there are sort of customers who do not want to completely exit the data center. They want to maintain their private data center on-premises workloads. But in addition, given the recent demands of their application stack, given the recent COVID and other pandemic issues, they still want to be able to expand pretty quickly into into more environments. Could be multiple sites, multiple geos, or just have the ability to quickly spin up workloads, which is sometimes not possible in the private cloud, the private data centers, due to lead times of hardware, of maintenance, and all of that. So data center expansion is coming up as a key requirement where you want active topologies to be running in hybrid mode. In addition, as the pandemic showed, there is a there's a push towards working from anywhere, which means more virtualization, desktop virtualization such as Horizon VTI happening in the cloud. So what was typically a private data center scenario or a use case now has extended to public clouds such as Horizon Cloud on Azure or Horizon running in Azure VMware Solution. So those also require some amount of requirements around the application delivery space. And finally, disaster recovery. This has always been a classic use case for multiple sites, right? Similar to active-active, but in this case, you have a DC and DR disaster recovery scenario. However, one of the key changes which we're seeing is that instead of having two private sites, you could have, our customers could have the secondary side or the standby side in public cloud as well. And there, again, they have choices. For example, they could just use the native public cloud or the Azure, or they could use Azure VMware Solution. So all of these are newer or incremental or revolutionary challenges to the application stack, to the IT infrastructure requirements from a load balancer as well. And what we'll see in the next few slides is how Avi is positioned in a way that this eases the journey as we move to a more hybrid cloud approach. A very quick intro to Avi, or to the VMware NS6 Advanced Load Balancer. I'm not going to go into too much detail. We have other webinars which are linked later at the end, which you can go through. But Avi is an enterprise-grade load balancer. It's a layer 4 through layer 7 application delivery controller providing local load balancing, GSLB or global load balancing, web application firewall, and application security. We were founded in 2014, and we got acquired by VMware in 2019. So it's been just about 2 years as part of VMware. As you can see, we have a full stack of features, as you can see on the left side, along with integrations into any of the ecosystems where you would be running your workloads, be it on-premises, for example, vCenter-based environments, pure x86 or bare metal-based environments, OpenStack, public clouds such as Azure, Amazon, Google Cloud, any of the top public cloud providers, as well as the VMware solutions such as VMC, Azure VMware Solution, and Google Cloud VMware Engine. On the right side, you can see some of the integrations which we have been doing in case of both pre-acquisition and after that. So specifically around VMware. We, of course, do a very good job in terms of integrating with vCenter and NSX. In addition, we've been working on solutions such as Horizon, ensuring that we provide the same level of automation and cloud native experience when you're running on a VMware Cloud Foundation stack or a VMC stack or Azure VMware Solution. And finally, we're also integrating with some of the tools such as the VRO and the VRA for automation, login sites for logging, all of the other tools which VMware provides. So the vision, of course, is to have Avi be able to deliver any app on any cloud with one platform, which is very consistent with what VMware's message is. How do we do that? Very quick intro into the technical aspect of the architecture. Basically, the Avi system is not an appliance. It's a software-only solution where we have a distributed architecture. The controller, which you see on top, is the brains of the system. It is the entity which you deploy, either in your premises, in your data centers, or it could be a SaaS service as well. The controller, in turn, connects to your environments. For example, it could be your vCenter, it could be your public cloud like Azure Virtual Network and Resource Shops, it could be your Azure VMware Solution as DDC. And from that, it deploys these data path instances, which we call service engines, the three you see over here in the bottom half. With that, given that the provisioning, the lifecycle of the service engines, all of the configuration is automated, this provides for a very consistent set of features across whatever environment you're running this on. Whether you're running it on vCenter, all of the programming of the virtual NIC, of the VNIC, ensuring that the correct IP addresses are provided to the data path, the web placement, all of that is taken care of using vCenter APIs from the controller to the vCenter. Similarly, in public cloud as well, as we see, we will use Azure APIs to do the same thing with Azure VMware as well. So with that, you maintain the fabric approach to load balancing, similar to what you have with compute with VMware vCenter, similar to what we have with storage with vSAN. What we have done over here is we have made we have basically virtualized the load balancing space and made it easier for you to consume. In addition, some of the key benefits which we get out of this is centralized orchestration. So if you have multiple sets of load balancers, as an enterprise, you will have 10, 20, 30 appliances running active standby. You don't have to manage them separately. They're all managed, the lifecycle is managed by the controller over here. And it's not just an instance manager where you connect the appliances over here. It actually figures out if an additional one is required in terms of redundancy or in failure and spins up one more as required. Elasticity, as I just mentioned, if you want to grow, all you have to do is provide policies which automatically ensure that your applications are available. And as the load increases, the number of service engines or load balancers also increase. And when your Black Friday sale or major tax event is done, then these resources are then scaled back in as well without you having to do anything much. Right. Resilience, as I mentioned, the control plane is a cluster of 3. It is also available as a SaaS service. The data plane as well is also active. So you don't have you have full redundancy along with minimized wasted capacity, because you're not running active standby, which would mean that 50% of your 50% of your capacity is just unused until there's a DR. Automation and analytics. So these are some of the things which should have been there for all our computers as well. But we've been able to really provide this in a way which is very useful to you. And we'll see that in our demo as well. When I say automation, what we have is a 100% REST API approach. So whatever you see on the UI of the Avi controller, whatever APIs are used, all of those are natively REST APIs. The CLIs themselves are also actually converted into REST API calls. But that it is very easy for us to integrate into third-party systems. Could be Splunk, for example, for logs, could be Grafana for metrics, could be ServiceNow and PagerDuty and things like that. So all of that is possible from the controller itself across all these environments. And finally, from an analytics perspective, we have around 600 plus metrics as well as end-to-end logging of each of these requests which come in, which can be used to provide a lot of insights into how your applications are doing. If there is any issue, then we'll see how we can troubleshoot that. So coming to a summary of the product capabilities, as I just mentioned, this platform or the fabric which we provide provides for all of these key aspects, such as orchestration, resilience, automation, and elasticity. And we do that across all the 4 pillars or 4 use cases which we see for application delivery. We have local traffic management or local load balancing. We have GTM or global load balancing for multiple sites. We have application security and web application firewall, as well as container ingress services if you want to run as an ingress controller. And all and the key aspects around the analytics and observability are all available across each of these systems in a very consistent way. Touching over WAF very briefly. So Avi has a WAF which has been there for more than 4 years now. Initially, when we started, what we wanted to do was leverage our fabric approach, as I mentioned, with great analytics, with the great user friendliness in terms of configuration, and provide the similar experience. So initially, we started with a signature-based OWASP top 10 core rule set approach to WAF, and that was version 1. Today, in addition to that, we also have a bunch of other features, the key being a qualitative security model. So instead of it being a core CRS-based system, we can actually learn the application behavior and then apply that as rules for positive security. So the system is constantly learning about the application and then ensuring that whatever traffic it gets is actually trained and properly allow listed before it being passed through to the application server. In addition, we also work with IP reputation feeds. We have included bot detection capabilities in the recent release, which came out last week, as well as threat feeds and signature feeds coming in to our services. So that was a very, very quick overview of what Avi is in general. Now we'll take some time to look at how we integrate with the public clouds such as Microsoft Azure and Azure VMware Solution. So in case of Microsoft Azure, we have major customers who have been using this using Avi for load balancing requirements in the public cloud in Azure. And the way we do that is the control plane, as I mentioned, could be deployed within the Azure system. It could be on premises as well, connected via Express Route or VPN, or it would be a SaaS. The control plane connects to the Azure public endpoints, to the IEM endpoints, to the virtual networks, all of these resources, and it discovers the system which is there. So once it has access, it can deploy these service engines, which are smaller, compute engines in the Azure public cloud, in the Azure VNet. In addition, the backend servers could be virtual machine skill sets, could be a virtual machine, of course. So we can also leverage auto scaling, where the controller can auto scale not just itself or the service engine data plane capacity. It can also auto scale the virtual machine skill sets as required and add it to the pool members. In addition, we integrate with various DNS providers in case of public cloud with Azure DNS, as well as with AWS Route 53 or a custom DNS as well. This is so that you can provide the FQDN as well as the public IP to the DNS provider, and that gets hosted on the Avi virtual service. A look at how the deployment looks like. We do have a couple of other solution briefs as well. We want to go into the details. But in this case, I have the Avi controller cluster, which is deployed in a single VNet. And I'm showing multiple VNets and resource groups over here, just to showcase the fact that the same controller cluster can handle multiple virtual networks, multiple environments. For example, if you have a hub and spoke topology, you could use that as well. With the same controller. It doesn't have to be one controller plus per environment. Okay. So in this case, once the controller has the requisite permissions, it will automatically create and manage these service engines. It will ensure that the application pool members or the skill sets are added to the pool members automatically. The Azure load balancer is provisioned in front, and we do this so that we can leverage the ECMP or the proportional scale out. So what Azure LB provides. So Azure LB is basically a layer 4 load balancer, and with that, the backend of that being the Avi service engines, we're able to provide linear scale performance as we add more service engines to the same application or the same virtual service.
Hey,
In addition, we can, yeah.
Yeah, so there is a question you might want to answer. Somebody's asking that they have applications which are running on on their appliance-based solutions, but they're facing some elasticity and performance issues. So how does Avi help with that? In the Azure environment?
Sure, that's a great question. So in case of issues around performance, right, it's always a challenge to look at where the performance bottleneck lies. In some cases, it's difficult to gauge which part of your stack has some inconsistency or a bottleneck. With Avi, as we'll see in the demo, we provide a bunch of analytics as to whether what the network round trip times or latencies are, what the on the client side, what the application side latencies are, how much time is being being spent on waiting for the application response. Right? So all of that information is available, and that provides with a very good view as to what the where the slowness in terms of performance is coming in. In addition, from a capacity perspective, let's say you're looking at some cases where performance degrades at high load. The metrics which we provide in terms of the load balancer itself in real time, as well as at very short granularity, provides information as to how much loaded the CPU was, how much bandwidth we were using. Right? So all of these are very good to be able to get into what the actual limitations of the stack are, and what you want to have to increase to be able to get better performance. So coming to the traffic flow, just go through this very briefly. Uh, Typically, the customer comes in from the external side, or could be an internal, internal client. It reaches the web, which is hosted over here, and then the Avi service engine routes it to one of the pool members, which is the application servers. On the back on the return traffic, once the application server responds to the service engine, the traffic goes back to the application to the external client. Before we go into Azure VMware Solution, just want to call out a couple of scenarios where we had, or use cases where we, specifically in Azure, where customers use us. One was Adobe, who used us when they started their cloud journey and when they were migrated to Microsoft Azure. They were looking for something which provided a rich set of features as well as high performance in the public cloud space, and they did a pilot with Avi and were able to to then deploy it for some of their very high performance, high demanding workloads. Similarly, Norton-LifeLock, which is Symantec, is also a public reference who started with using Avi as they were migrating into Microsoft Azure, and they've been using us for both for application load balancing as well as for WAF. So we saw how we integrated with Azure. Let's see how we look, what we do with Azure VMware Solution. So very quick intro for Azure VMware Solution. So this is a service provided by Microsoft, and it is validated by VMware as well. Underlying it is the VMware Cloud Foundation or VCF stack. This is attractive because now you can actually seamlessly run, manage, and secure applications across VMware environments as well as Microsoft Azure with a common operating framework. So you will not have to do application refactoring uh, if you wanted to just very quickly add capacity while retaining your VMware stack. This provides you with a way to do that. In addition, the workloads on Azure can very easily be modernized through integration with Azure services. For example, Azure Active Directory, Azure AI, Analytics. So these provide you with some of the expansion and new services which you may be looking at.
So this looks great, Abhinav, but we have a question. So, somebody's asking that, so if I have my VMware workloads and I want to move them to Azure, so I create a private cloud through the Azure portal. So does that mean that now I will be able to use Avi load balancing? The integration is all complete. Like, will I have the ability to do that today?
Sure. Yeah, so that's what some of the next slides in the demo will show. But today, if let's say you have an on-premises data center as well as you're extending into Azure VMware Solutions, you have multiple ways that you can integrate. In this case, what we're seeing is that the Azure VMware Solution AVS SDDC has its own NSX manager, it has its own vCenter. And the Avi controller can be deployed within the SDDC. The controller, then as we saw earlier, also deploys the service engines in a fully automated way. So with that, you can use the same sort of experience which you have on premises with Avi in AVS as well. Some more details into how that does. In case of AVS, what we do is we actually leverage our NSXT cloud connector. So what we do is we integrate via the NSX APIs to the NSX manager, as well as with the vCenter APIs to the vCenter server. With that, the controller will discover all the NSX and vCenter infrastructure within the Azure DC. For example, logical segments, transport zones, all of that. And with that, you'll be able to automate the provisioning of these service engines within the NSX and vCenter environment. If you have an on-premises NSX-based data center, then this will be very familiar to you in the similar way. This shows how we actually do a virtual service creation. So in that case, the LB admin or an application admin. So you don't have to be the person who's doing this for your application owners. Avi controller is fully role-based access control or RBAC enabled. So you could provide operator access to the controller, or you can use self-service tools such as VRA to drive the virtual service creation. And once you do that, the controller actually deploys the service engine then on there using the vCenter APIs. And then it ensures that it creates the various routes on the T1 for service engine access, ensures that it leadership has groups and the other services.
So Abhinav, one of the question that we have is that if you go to the previous slide, can I cross launch my Avi controller through NSXT manager?
Good question. The NSXT manager will be able to launch the controller in a future release. I think it's in the next couple of months. So with that, the controller, if you want to manage the lifecycle of that in terms of deployment as well as some of the configuration, will be possible through the NSX manager as well. In case of the AVS solution, though, this is on a previous version of NSX Manager, so it will be a while before that feature comes in. Of course, that is in case of AVS, the full set of features is available using the Avi controller as well. So that should satisfy most of the requirements in general in case of AVS deployments.
Okay, thank you.
So let's look at some of the use cases which we mentioned and how they get enabled. Right? The first one which we wanted to cover was the active-active or expansion use cases. Right? So in this case, you would typically have an on-premises data center which you would like to retain. In addition, one or more of AVS or Azure public cloud SDDCs. In that case, what you could do is you've already probably extended your application into these environments. The application is running in 2 or 3 of these environments, right? What you could do is ensure that you have Avi running as a local load balancer. In addition, the Avi GSLB service could be used so that it provides you with active-active approach to load balancing. So let's say a customer comes in uh, and based on the geography, if let's say they're in the US, the United States area, they could come to the on-premises data center, which is in the US. Whereas a user coming from, let's say, Europe or Asia Pac could go to some other site, which is also active, based on the geographic proximity. So those kind of scenarios are enabled both by having hybrid environments and by having something like GSLB running for your major applications. In addition, if you want to expand to one of the public clouds like AWS or Azure for let's say a period of time, let's say you have we saw that in the pandemic situation where you suddenly had to have capacity augment your on-premises capacity, right? So that's the case where both the Avi local load balancing running and deploying on your new public cloud environments, as well as GSLB to stitch all together is very useful.
So a quick question on GSLB deployment, Abhinav. The question is that, how can I configure proximity-based GSLB with Avi?
Sure,
And
yeah,
how can
absolutely. So
I do that?
yeah, Avi comes with a GODB with granular information, up to I think city level in the US. So that is already available by default with IP address mappings, right? So that can be enabled for proximity-based load balancing. In addition, you could also have your custom GODB, which Avi supports. So you can provide your own, IP address to latitude, longitude mappings that could be used for proximity, especially in cases where, for example, let's say it's a small area and you have multiple data centers, let's say in the same region, right? So the default IP mappings will not be of use. So you could use your own private IP mappings as required. In addition, we have multiple tiers of decision making is available as well. So you could have one level of load balancing happening, let's say on proximity, and the other on some other parameters as well. The other key use case which we are seeing, especially with Azure VMware Solution, is migration off of an on-premises data center to Microsoft Azure or Azure AVS. So in this case, what you would want is you already have a original site, which you probably have a plan to vacate after things have been migrated. So you could run Avi as a load balancer, or even if it's not as a load balancer in your on-premise data center, you would still leverage GSLB. So just have Avi GSLB connect to the third-party load balancer, which is there. The site 2, which is the final site, is where you would configure the secondary site as a GSLB as well. Once you have the applications refactored or migrated onto the secondary site, you could just go and switch off the site, the first site, and then ensure that the DNS points only to the final site. So with this, what you would have is cases where you want to migrate off of on-premises into Azure VMware Solution or AWS SDDCs, and then continue to use Avi over there, both for local load balancing as well as GSLB. The final use case which we have is a classic one, which is the DR. So in this case, you would you may be running one site or multiple sites as active and have a backup site in AVS. Right? So the backup site is fully primed. It has its own application stack, either in a bomb state or a standby state, as well as GSLB running between these two sites, with the second site at a lower priority, so it's on a standby. So typically the traffic will come to the primary site. However, if let's say the site goes down, the GSLB algorithm on the Avi will be able to detect that, and it will ensure that it does not advertise the DNS for the IP for this site in the future. And with that, all the upcoming traffic, the subsequent traffic, will come to the backup site, which gets promoted to another site. Right? So with this, some of your disaster recovery SLAs and your business continuity programs are able to leverage AVS as well. We're also seeing this happen with Horizon. So we've seen a couple of customers who were already deployed on Horizon VDI on premises in multiple sites, but they want to ensure that they have a backup site in AVS, and they've been able to use AVS as a secondary or tertiary backup site running Horizon VDI only for disaster recovery. Surbhi, Vijendra, any other questions before we get to the demo?
None so far. We're excited to see the demo, Abhinav.
Sure. So let me just switch to my browser. I'm hoping you can see my screen.
Yes.
So, so what we have over here is the Avi controller user, and I just logged in. This is a fully role-based access control enabled system. So as you can see, I have multiple tenants over here. Currently, I'm in the admin tenant, but I have other tenants which host applications as well. So when I log in, I get into this virtual service application dashboard view. Let me just walk you through the life cycle of deploying Avi. So typically, you would deploy the Avi controller, which is the UI you're seeing as an OVA file in vCenter, either on premises or in case of AVS within the Azure DC. In case of Azure, it is available on the marketplace for free with a BYOL license. So one thing which I wanted to also note over here is from a licensing perspective, Avi is today licensed only on the data plane capacity. So the controller or the control plane is effectively free. What we license on in a 1 year, 3 year term is the is the service engine core capacity, which we call service core. This is the amount of compute which you need for the data plane only. And because of that, we come out as a very attractive from on a 3 year to 5 year TCO from a competitive perspective. So coming to the day zero configuration, you have deployed the controller. After that, what you have to do is one time connect it to the environment where your applications are. In this case, this controller has been connected to multiple cloud environments. I've connected it to a vCenter cloud. I have it also connected to Azure as well as AWS. So when I say connection, connected to the cloud or provision this cloud connector, what do I mean? So over here, what I've done is I have provided it with a vCenter and vSphere credentials, as well as a vCenter address, the IP or FTDN. Once I do that and I click on next, the controller is making API calls into that vCenter environment. And it is actually discovering all of these objects from there. The reason to do that is that you don't have to go and then manually figure out what my management network should be, what are the data plane IP addresses I need, or data plane port groups I need to know for the VIP to be placed or to the backend servers to be reached. Similarly, we select the management network which is what the service engines will use to connect to the controller. Once that is done, the connection is done and the controller is ready for deployment of service engines. Similarly, on Azure, here we ask for a subscription ID as well as Azure credentials. So in this case, we ask for your Azure, role and control, basically the credentials. And again, as I click on next, we are doing real-time API calls into Azure and figuring out what are the locations available, what resource groups, what are the VNets, what are the submissions available. Right? So this one-time configuration is all that is required as an administrator. After that, you can hand over the limited application creation view to your application teams without having to be in the way of them. So note that at this point of time, we have not created the load balancers or the service engines. And the reason for that is we don't have a virtual service or an application which we are load balancing yet. Let me just configure one and show you what happens if I create a virtual service. So I'm being asked which environment the virtual service is where I want to create. I'm going to use basic setup as well as I'm just going to select VMware Cloud for now. I'll give it a name. With auto-allocate an IP address. So all of this information is being taken from the vCenter and from the Avi controller. Right? I can also select the virtual machines which I have to load balance over here. So I'm just going to do a search. Just select these add servers and I'm done. So at this stage, what the controller is doing is it is figuring out if a service engine already exists. If it does, all it does is it gets an IP address, it places this virtual service, the service engine on that, and you're good to go. So this service engine was already present. So the IP address is then hosted on that service engine. If the service engine was not available, which would be the case of your initial deployment, then the controller would have sent an instruction to vCenter to deploy the service engine. The service engine would have booted up in a couple of minutes, called back home to the controller, and after that, the configuration would be pushed through. So note that I didn't have to provide, the port group details, which where the application servers are residing, what the IP address is. All of that has been automated behind, and the controller actually intelligently manages this without you having to weigh in or micromanage all of this. That is the power of the distributed architecture and the API-driven approach which we've taken, and it is consistent across all the clouds, whether it is Microsoft Azure, whether it is AVS, it's the same. I think there was a couple of questions around analytics and observability and performance. So let me just show you some of the key aspects of the visibility which we provide. Right, this view, the dashboard view, which is the default which customers, user has put in, provides you with some very actionable items at a high level. For example, this is one of the virtual services which we have. We see that this is placed on 3 service engines. The health of these service engines are good. The VS is referring to 4 pools. Out of that, 3 are great. One of them has a bit of a performance penalty. Right? So this health score provides you with a good pictorial or overall view as to how the application is doing. In addition, you can see that one of the application servers is marked as down. And even without going into too many details, just on mouse over, we can see that this is marked down because ARP is unresolved. So effectively, one of the health monitors, the HTTP health monitor is not functioning. And the reason for that is not that, even the ARP is not there, which basically means that the VM itself is shut down or not available. Drilling down into this a bit more, by clicking on this, we get into the analytics view, which provides you with aggregate analysis over past 6 hours, past day, 30 minutes. And the intent of this to provide some of the key metrics, out of the hundreds of analytic metrics which we provide on the client side and the application server side, on the pull side. So just give it a couple of, a few seconds to load. Yeah, there you go. So over here, as you can see on the right side. Yeah, is there a question?
Yeah, no, I will let you finish this thought and this particular, and then I'll ask the question of him.
Sure. So in this case, as you can see on the right side, we have various, graphs or metrics available on the VS level. This one is an end-to-end timing view. And coming to that performance question which we had earlier, this tells us what the overall average aggregate, time taken is for the requests. So as you can see over here, the green, the lowest one is the client RTT. After that, the server RTT, as well as application response time. So even with just seeing this, you can see that we are noting down some cases where there is a spike in the parameter. And looking at this graph, you can see that it is not because of the client RTT. So the network looks great. There's an application response issue. So effectively, this means that some of the applications are misbehaving every few hours, causing some degradation to the customer or to the end user. Similarly, there are some of these throughput, graphs which tell you how much loading is there on the virtual service, how much applications are there, how many open connections, how many requests are coming in, and what the error rates are. So this provides you with a overall average, aggregate view, very useful for eyeballing and figuring out how the application is doing at a high level. Subir, do you want to
Right.
go to the question, or I can?
Right, Abhinav. So there's a question that you mentioned about the automation. So all these networking, application networking services which are delivered by Avi, like you just walked through. So we understand that they're fully automatable with REST APIs, but we use Ansible as a DevOps tool. So do you also offer any ready-to-use Ansible modules and roles? Can you comment on that?
Yeah, absolutely. So we have a very good, API, as I mentioned, API approach, REST API approach. So as you can see, I can go to the Avi API documentation right from the controller itself, and this provides us with a spec of the REST APIs. Now, these APIs can either be consumed directly as REST APIs. It could be consumed as SDKs, such as Python SDK, Go SDK. We have a Java SDK as well. In addition, we also have configuration management support with Ansible. So we have Ansible modules and now Ansible collections for all of the items which you want to do. We also support Terraform. So if you're using Terraform for your use cases, full Terraform provider is available as well. So depending on what your teams use, any of these is available. And the good part is that these are all generated from the Swagger UI. So there is no difference in the object model, whichever one you use. It is just the semantics, of that language or the tool which differ. Coming back to the, analytics demo. We looked at the analytics view, which was providing you with high-level metrics information, right? But what if you saw that there is an application server issue and you want to drill down on which application server is causing you issues, right? That's why we have the logs view. And again, this is something which every load balancer should be able to do. Every load balancer is sitting in line with your traffic. It is terminating SSL in most cases. You have a front-end client, TCP connection. You have a back-end server TCP connection. However, what we've seen is that Avi has been, the pioneer in being able to visualize and provide these actionable insights to customers. This view is one of the per request logs. So what we do is we take each of the requests at an individual basis. Of course, we throttle it for performance, and we provide you with insights and data points for each of these requests which come in. So one individual request which come in has all of this information which you can see, right? Basically the client state, this client came in from Japan based on the IP address, what device and all of that, whether it was a SSL transaction, what encryption algorithm, what the client identities and all of this is, what the application response time is, which server actually served this request, which service engine served it, as well as all the headers which got exchanged. So with this, you could drill down, using this some of the analytic queries which you could do, or you could use your own. So let's say you wanted to, troubleshoot a slowness being reported. So what you could do is just look at end-to-end timing. And let's see, we'll look at anything which is more than 600 milliseconds of total time, right? So what we're doing is we're drilling down or filtering on this and seeing, and then we can look at whether these are coming from a specific IP address. Right? So this is most are coming from one particular IP address. So you can go and say that, okay, this is the location which is causing a problem, right? Or you could look at the servers which are hosting these requests. Right? And you can see that most of these are on 2 or 3 servers. So you can drill down and see if the server has a problem. Similarly, let's say some of your customers are saying that I'm getting a frequent 404 or a file not found error, page not found error. I'll just go over here and filter by response code. So I can see that around 10% of my requests are 404s. Once I drill down, I can then look at whether it's a particular server which has a challenge, and I see 100% of these are on a server. So from a vague request or vague problem statement from a user that hey, I'm sometimes getting a 404 errors, we're able to say that this logo.png is not available on a particular server. That's the power of this the analytics which provide something which would take a matter of hours or days between multiple teams to troubleshoot is you can just provide this to your application teams to do this troubleshooting automatically or on their own. Similarly, we have a lot of insight into the security posture. For example, DDoS attack, the SSL ciphers being used, which TLS versions are being used. So all of this is very actionable information. If you, for example, tomorrow there is a vulnerability in one of the ciphers, you can come here and just see how many of what percentage of your users are impacted, and then shut those down or block those. So this is what I had from a demo perspective, and similar to this, what I showed you on the vCenter and Azure side, this is all available on AVS as well. So I have an AVS environment in Azure. This controller is running in AVS. Of course, it is not, it is not apparent that it is, given that it is the exact same product, it is the exact same integration. So in this case, just the fact that we are using some of these IP addresses as well as the underlying services within the AVS Azure DCU is all that is. But for an end user, it doesn't matter where the service is running, where your applications are running. It is consistent across all of these environments, which I showed. So this is what I had from a demo perspective. Coming back to the further resources which we have. So the slide deck also before we go into resources, just want to summarize what we learned today. We see Avi hybrid cloud deployments increase and continue to increase as more and more customers go for multi-cloud and multiple environment approach, especially with Azure as well as AWS. With that, we see the VMware stack as well as Avi being able to be positioned for various use cases you have. Could be scalability, which is on demand and cloud native. Could be some of the analytics features which we provide along with the product without any additional agents or additional requirements. We have end-to-end automation which we touched upon. So provisioning as well as troubleshooting as well as deployments, all of those can be automated with the existing tools. And finally, this is completely consistent across multiple environments, be it public clouds, hypervisors, SDDCs, you name it, and it's all very consistent. I added some resources specifically around Azure and AVS. In addition, the third link, which is the workshops, provides you with a view into if you want to learn more. We run a 90-minute as well as a 2-day workshop, which is currently virtual, where you can do a deep dive into the Avi technology. So feel free to use these. We also have a lot of other hands-on labs and test drives if you want to give this a shot. Surabhi, are there any other questions?
That will be all, Abhinav. That was really great. Thank you so much for walking us through this webinar and the great demo. So like Abhinav said, please, these slides are going to be given to you in the follow-up email, and check out these resources. Thanks all of you for your time, and have a great rest of the day. Thank you.
Thanks a lot, Ian. Thank you. Have a good day.